December 1944, the frozen forests of Belgium. A single American tank crew faces the unthinkable, Germany's most feared weapon, the King Tiger, advancing through the snow. The Americans are outnumbered, outgunned, and driving a tank their own generals almost cancelled. What happens next would rewrite the rulebook of armored warfare and prove that sometimes the underdogs carry the biggest punch. This is the untold story of how American ingenuity defeated Nazi engineering at its peak. The year was 1942, and the United States Army faced a devastating reality. Reports from North Africa painted a grim picture. American M4 Sherman tanks were being systematically destroyed by German panzer forces. The Sherman, America's frontline medium tank, was reliable and mass-produced, but it had a fatal weakness. Its 75mm gun couldn't penetrate the frontal armor of Germany's newer tanks. On November 8, 1942, Operation Torch began, marking America's entry into the North African campaign. Within weeks, tank crews discovered what British forces already knew. The German Panzer IV, equipped with long-barreled 75mm guns, could destroy Shermans from distances where American tanks couldn't fight back. Even worse, intelligence reports warned of something more terrifying. Germany was developing super heavy tanks with armor so thick that no Allied weapon could stop them. The U.S. Army Ordnance Department convened emergency meetings in early 1943. General Jacob Devers, commanding Army ground forces, demanded a solution. American tank crews were brave, but bravery couldn't overcome physics. When a Sherman's 75mm shell bounced off German armor, it meant death for 5 American soldiers inside. The Ordnance Department knew they needed a tank destroyer, a vehicle with firepower capable of defeating any German armor. But there was fierce debate about the design philosophy. Some generals wanted a fast, light vehicle that could ambush and retreat. Others demanded heavy armor for head-to-head combat. The American military doctrine emphasized mobility and mass production over individual vehicle superiority, a philosophy that had served them well, but was now being challenged by German engineering. In January 1943, the Ordnance Department issued specifications for a new heavy tank destroyer. It needed to mount a gun powerful enough to defeat 200mm of armor at 1,000 yards, the projected protection of Germany's rumored super heavy tanks. The vehicle had to be mobile enough to keep pace with advancing infantry. And critically, it needed to be producible in American factories without disrupting existing Sherman production. Multiple designs competed for approval. Fisher Tank Division proposed a heavily armored assault gun. Ford suggested a massive turretless design. But one proposal stood out for its audacity. The Detroit Arsenal, led by engineer Henry J. Hatch, proposed mounting a naval gun on a tank chassis. Not just any naval gun, but a modified 90mm anti-aircraft gun, a weapon designed to destroy bombers at 30,000 feet. The idea seemed absurd to many officers. General Leslie McNair, architect of American tank destroyer doctrine, initially opposed the concept. He believed tank destroyers should be lightly armored and fast, trading protection for firepower and speed. A vehicle mounting a massive 90mm gun would be heavy, expensive, and contrary to established doctrine. McNair's opposition nearly killed the project before it began, but events in Europe forced a reconsideration. On July 5, 1943, Germany launched Operation Citadel at Kursk, deploying their new heavy tanks en masse. Intelligence reports described monsters: the Panther with sloped armor, the Tiger with an 88mm gun, and rumors of even larger designs. The reports terrified Allied commanders. If Germany could field dozens or hundreds of these vehicles, the invasion of Europe might fail before it began. The pressure mounted through summer 1943. American forces needed a counter to German heavy armor, and they needed it fast. The question wasn't whether to build a heavy tank destroyer anymore. The question was which design would save American lives in the coming invasion of Fortress Europe. The T-95 gun motor carriage project officially began in March 1943, but it faced immediate opposition from the highest levels of military command. The vehicle that would eventually become the T-28 Super Heavy Tank started its life. Surrounded by controversy and doubt, Henry J. Hatch and his engineering team at Detroit Arsenal worked frantically. Through spring 1943, their design was revolutionary but problematic. To mount the 90mm gun and provide sufficient armor protection, the vehicle would weigh over 95 tons, making it the heaviest American armored vehicle ever conceived. It would require a specially designed suspension system, with 2 sets of tracks on each side, 4 tracks total, to distribute the massive weight. The Army Ordnance Committee reviewed the preliminary designs in May 1943. The opposition was fierce. General McNair argued the vehicle violated every principle of American tank destroyer doctrine. It was slow, with a maximum speed of just 8 miles per hour. It was expensive, costing approximately 5 times more than a Sherman tank. Most damning, it couldn't cross most European bridges, limiting its strategic mobility. Colonel Willis D. Crittenberger, commanding the Armored Force Board at Fort Knox, issued a scathing report in June 1943. He calculated that for the cost of one T-95, the Army could produce 5 M10 tank destroyers or 3 M4 Shermans. In a war where industrial capacity determined victory, this seemed like an impossible trade-off. Crittenberger recommended the project be terminated immediately, but the T-95 had a powerful advocate. General George S. Patton, though primarily focused on offensive operations, understood the psychological impact of heavy armor. In July 1943, after reviewing intelligence reports from Sicily, Patton sent a telegram to the War Department. He described watching German Tiger tanks destroy American positions with impunity and the devastating effect on infantry morale. Patton argued that America needed a weapon that could stand toe-to-toe with the heaviest German armor, even if produced in limited numbers. The debate intensified through summer and fall 1943. Engineers proposed modifications to address the criticisms. They designed a system where the outer tracks could be removed for transport, reducing the width from 14 feet 11 inches to 10 feet 4 inches, allowing rail and limited bridge crossing. The armor was redesigned using cast and rolled plate combinations, improving protection while controlling weight. The gun mount was refined to provide better accuracy and faster reload times. In November 1943, intelligence reports confirmed Germany was developing the Jagdtiger, a super heavy tank destroyer mounting a 128mm gun. The War Department reconsidered the T-95 project. If Germany could field such monsters, America needed a counter. On November 29, 1943, the Ordnance Department authorized the construction of 5 pilot vehicles, but the authorization came with severe restrictions. The T-95 would be classified as an experimental vehicle, not a production model. No mass production would occur until the pilots proved their worth in combat trials. Most critically, the project received low priority for steel allocation and manufacturing capacity. Sherman production couldn't be disrupted, even for a potentially war-winning design. The Detroit Arsenal team began construction in December 1943, but progress was agonizingly slow. Critical components were delayed by higher priority programs. The specialized tracks required new manufacturing processes. The 90mm guns needed modification to fit the tank mount. Engineers worked through the winter, knowing that soldiers were dying in Europe while they struggled with blueprints and metallurgy. By March 1944, as the Allied invasion of Europe approached, the first T-95 pilot was still months away from completion. The rejected design remained stuck in American factories, while German heavy tanks dominated European battlefields. While American engineers struggled with their rejected design, Germany unleashed its most powerful weapon. The Panzerkampfwagen Sig Ausf. B, known to the Allies as the King Tiger, or Tiger II, represented the pinnacle of German tank design and the nightmare of every Allied tank crew. Development of the King Tiger began in January 1943, when Hitler personally demanded a super heavy tank that would dominate any battlefield. German engineer Dr. Ferdinand Porsche competed with Henschel and Sohn for the contract. After extensive trials at the Kummersdorf Proving Grounds, the Henschel design was selected in October 1943, and production began in January 1944 at the Henschel plant in Kassel. The specifications were staggering. The King Tiger weighed 69.8 tons, nearly double the weight of a Sherman. Its frontal armor measured 150 mm thick and sloped at optimal angles, making it effectively impervious to any Allied tank gun at normal combat ranges. The side armor measured 80 mm thicker than most Allied tanks' frontal protection. This massive armor meant the King Tigers could advance across open ground, while Allied tanks desperately tried to find weak points. But armor was only half the story. The King Tiger mounted the fearsome 8.8 cm KWK 43L71 gun, a weapon of devastating power. This long-barreled cannon could penetrate 165 mm of armor at 1,000 meters, using standard ammunition, and even more using special tungsten core rounds. In practical terms, a King Tiger could destroy any Allied tank at ranges exceeding 2,000 meters, while remaining invulnerable to return fire. The first King Tigers reached combat units in May 1944. The 503rd Heavy Panzer Battalion received 45 King Tigers and deployed to Normandy, just after D-Day, June 6, 1944. The psychological impact was immediate and devastating. British and American tank crews reported the horror of watching their shells bounce harmlessly off King Tiger armor, while the German vehicles systematically destroyed Allied positions. On June 13, 1944, near Villers-Bocage, a single King Tiger from the 101st SS Heavy Panzer Battalion engaged British forces. Over 3 hours of combat, this single tank destroyed 11 British tanks and numerous support vehicles before withdrawing without significant damage. The engagement terrified Allied commanders. If one King Tiger could do this, what would happen when Germany fielded hundreds? German propaganda maximized the King Tiger's impact. Newsreels showed the massive tanks crushing obstacles and destroying targets at impossible ranges. Hitler personally visited King Tiger units, posing for photographs with these symbols of German technical supremacy. For German soldiers retreating on all fronts, the King Tiger represented hope that wonder weapons might still achieve victory. By August 1944, approximately 120 King Tigers were in service on both eastern and western fronts. Each one required tremendous resources, 300,000 man-hours to produce, specialized steel alloys in short supply, and highly trained crews capable of operating such complex vehicles. But Germany committed these resources because the King Tiger achieved results. In properly conducted defensive battles, King Tigers destroyed Allied tanks at ratios exceeding 10-1. The Allied response was desperate improvisation. Tank crews learned to target tracks and gun barrels, hoping to disable rather than destroy King Tigers. Artillery was called down on King Tiger positions, trying to score lucky hits on thinner top armor. Most effectively, Allied fighter bombers hunted King Tigers during movement, when they were vulnerable and separated from support. But by autumn 1944, as the Allies approached Germany's borders, the King Tiger remained the most feared weapon on the battlefield. No Allied tank could fight it on equal terms. Something had to change, or the final battles for Europe would cost thousands of American lives. Throughout summer 1944, as Allied forces fought through Normandy's hedgerows, American engineers worked desperately to complete the T-95 program. What began as a rejected design had become America's hope for countering German super heavy armor. But time was running out. The first T-95 pilot vehicle was finally completed in June 1944, the same month as D-Day. It immediately went to the Aberdeen Proving Ground in Maryland for initial trials. The test results were mixed. The 90mm gun performed spectacularly, delivering the promised armor penetration. The four-track system distributed weight effectively, but mechanical problems plagued the prototype. The transmission overheated during sustained operations. The tracks threw frequently, requiring hours of repair work. The complex suspension suffered stress fractures. Lieutenant Colonel John K. Christmas, head of the test program, submitted his report in July 1944. He noted that while the T-95 possessed unmatched firepower, its reliability was unacceptable for combat operations. The vehicle needed extensive redesign before it could serve effectively. This report nearly ended the program. With Allied forces ashore in France and advancing, some officers argued that the war might end before the T-95 could deploy, making the entire project wasteful. But intelligence from Europe changed everything. In August 1944, the Battle of Falaise Pocket demonstrated the King Tiger's capabilities in defensive warfare. Small numbers of King Tigers fighting from prepared positions inflicted devastating casualties on Allied armor. Reports reached Washington describing Allied tanks burning by the dozens, destroyed by an enemy they couldn't even damage in return. General Dwight Eisenhower, Supreme Allied Commander, personally intervened. In a classified message dated August 18, 1944, Eisenhower requested that the T-95 program receive highest priority for completion. He stated that without a vehicle capable of defeating super-heavy German armor, the final assault into Germany might cost tens of thousands of American lives. Eisenhower's support revitalized the project. Engineers worked around the clock through fall 1944. They redesigned the transmission using components proven in the M26 Pershing Heavy Tank program, which was running parallel to the T-95. They modified the track system, improving reliability. Most importantly, they upgraded the 90mm gun ammunition, developing special armor-piercing rounds with tungsten cores that could penetrate even greater thicknesses of armor. A second pilot vehicle, incorporating these improvements, was completed in October 1944. The Aberdeen tests resumed in November. This time, results were far more promising. The T-95 achieved its design speed of 8 miles per hour consistently. More impressively, in firing tests against captured German armor plates, the 90mm gun penetrated 200mm of armor at 1,000 yards, exceeding the original specifications. Lieutenant Colonel Christmas submitted his revised report on November 28, 1944. He recommended immediate limited production of 25 vehicles to be deployed to Europe for operational trials under combat conditions. The Ordnance Department approved this recommendation on December 2, 1944. Production orders went to the Pacific Car and Foundry Company, with delivery scheduled for spring 1945. But events were about to overtake this cautious timeline. On December 16, 1944, Germany launched its last major offensive in the West, Operation Wacht am Rhein, known to Americans as the Battle of the Bulge, saw King Tigers and other heavy German armor smash into lightly defended American positions in the Ardennes forest. The desperate fighting that followed would finally create the conditions where the T-95's capabilities could be properly demonstrated. The rejected designs moment was approaching, though few yet realized it. The race against time was about to become a race against German steel and American blood. December 1944. brought chaos to the Western Front. Hitler's desperate gamble in the Ardennes caught American forces off guard, and German heavy armor exploited the breakthrough with devastating effect. In this crucible of combat, American armor doctrine faced its ultimate test. The Battle of the Bulge began at 5:30 a.m. on December 16, 1944, with a massive artillery barrage along an 80-mile front. Within hours, German armored spearheads, including King Tigers from the 501st Heavy Panzer Battalion, penetrated American lines. The weather grounded Allied air support, eliminating the one advantage that had previously countered German heavy tanks. For the first time since D-Day, German armor operated with near impunity. The fighting around St. Vith demonstrated the crisis. From December 17 to 23, American forces tried desperately to hold this crucial road junction. German armor, including approximately 18 King Tigers, hammered American positions. Sherman tanks attempting to defend the town were destroyed at ranges where they couldn't effectively return fire. American tank crews showed tremendous courage, closing to point-blank range to hit King Tiger weak spots. But the cost in lives and vehicles was unsustainable. General George Patton's Third Army wheeled north to relieve the surrounded town of Bastogne, but even Patton's aggressive tactics struggled against German heavy armor. On December 22nd, elements of the 4th Armored Division encountered King Tigers near Chaumont. The battle lasted 3 hours and cost the Americans 14 Sherman tanks. The King Tigers withdrew only when their ammunition ran low, having suffered no permanent damage. By Christmas Day 1944, American casualties in the Bulge exceeded 80,000 men, with hundreds of armored vehicles destroyed. The desperate fighting produced a flood of after-action reports, all reaching the same conclusion. American armor was outmatched in direct combat with German super heavy tanks. Something had to change. At Aberdeen Proving Ground, the urgency finally crystallized. The second T-95 pilot vehicle had completed its tests, and a third pilot incorporating final improvements was nearing completion. On December 28, 1944, a demonstration was arranged for senior officers, including representatives from Eisenhower's headquarters. The demonstration would determine the T-95's fate. The test was simple but dramatic. Engineers set up a captured German Panther tank's frontal armor plate at 1,000 yards, the standard combat engagement range. A Sherman fired first, using standard armor-piercing ammunition. The shell bounced off, leaving only a crater in the surface. Then the T-95 fired. The 90mm shell, traveling at 2,800 feet per second, punched completely through the plate, leaving a clean hole that would have killed everyone inside a real tank. Additional tests followed. The T-95 engaged targets at ranges up to 2,000 yards, demonstrating consistent penetration of the heaviest German armor. Its own thick frontal armor, 305 meters at its thickest point, proved effectively immune to captured German 88mm guns. Most impressively, despite its 95-ton weight, the T-95 demonstrated acceptable mobility in the muddy conditions simulating European winter terrain. The officers watched in silence, then reached their decision. On December 30, 1944, new orders went out. The cautious plan for 25 vehicles was abandoned. Instead, the Ordnance Department authorized immediate production of 100 T-95 vehicles, later redesignated as T28 Super Heavy Tanks. More importantly, the 3 completed pilots would be shipped to Europe immediately for operational trials under combat conditions. The rejected design had proven itself on American proving grounds. Now it would face the ultimate test: combat against the King Tigers in the frozen forests and shattered cities of Europe. January 1945 marked a turning point for American armor in Europe. As bitter winter fighting continued in Belgium and Germany, the first T-28 Super Heavy Tanks prepared for deployment to the European theater of operations. The logistics of moving these behemoths would prove almost as challenging as building them. The first T-28, officially designated T-28 GMC Pilot DO 1, completed final modifications at Aberdeen on January 8, 1945. Its combat weight of 95 tons created immediate transportation problems. No standard military transport could carry it. The vehicle was too wide for most roads, too heavy for most bridges, and too large for standard rail flat cars. Engineers had designed the removable outer track system specifically for this problem. But removing and reinstalling the tracks required 6 hours and a trained crew. The solution involved a complex transportation plan. The T-28 would travel via specially reinforced rail flat car to the port of Newport News, Virginia. There it would board a heavy transport ship modified to carry extra heavy cargo. The voyage across the Atlantic to Le Havre, France, would take approximately 12 days, depending on convoy schedules and U-boat activity. Once in France, the T-28 would move by road to forward positions, but only along routes specifically surveyed for bridge weight capacity. Pilot number 1 shipped from Newport News on January 15, 1945. Pilot number 2 followed on January 28th. Pilot number 3, the most refined version, incorporating all previous test results, would remain at Aberdeen for additional trials and crew training. The War Department authorized the formation of a special test unit, designated the 836th Tank Destroyer Battalion Provisional, specifically to evaluate the T-28 in combat conditions. The 836th was an unusual unit. Its personnel were handpicked, experienced tank destroyer crews who had proven themselves in combat, combined with technical experts who understood the T-28's complex systems. Captain James Parker, a veteran of the North African and Italian campaigns, took command. Parker had lost his previous command, an M10 tank destroyer, to a Tiger I during the fighting at Anzio. He understood intimately the problem the T-28 was designed to solve. Training for the T-28 crews began in February 1945 at a facility near Verdun, France. The soldiers discovered that operating the T-28 required different tactics from standard tank destroyers. Its slow speed meant it couldn't conduct the hit-and-run attacks that characterized American tank destroyer doctrine. Instead, the T-28 excelled at deliberate, prepared combat, where its superior firepower and armor could dominate. Crews learned to position the vehicle in defensive positions or to advance slowly behind infantry, destroying fortified positions and heavy enemy armor. By late February 1945, as Allied forces prepared to cross the Rhine River and enter Germany itself, the T-28s were ready for combat evaluation. Intelligence indicated that Germany was concentrating its remaining King Tigers and Jag Tigers to defend the Rhine crossings. This would provide the perfect test. American and German super heavy armor meeting in direct combat. The deployment plan called for the T-28s to support the 9th Armored Division during the Rhine crossing operations. They would move into position near Remagen, where American forces had unexpectedly captured the Ludendorff Bridge intact on March 7, 1945. German counterattacks to destroy the bridge included heavy armor, providing exactly the target-rich environment where the T-28 could prove its worth. As March 1945 began, American soldiers manning the fragile Remagen bridgehead faced fierce German counterattacks. Unknown to most, the ultimate American tank destroyer was moving into position, ready to face Germany's finest armor in the war's final battles, March 12, 1945. The Ludendorff Bridge at Remagen had been in American hands for 5 days, and German High Command was desperate to eliminate the bridgehead. Intelligence indicated a major counterattack was imminent, including heavy armor from the 506th Heavy Panzer Battalion equipped with King Tigers. This would be the T-28's baptism of fire. Captain Parker positioned his 2 T-28s carefully. The terrain around Remagen consisted of rolling hills with scattered forests intersected by narrow roads, typical of the German Rhineland. Parker placed T-28 pilot number 1, call sign Anvil, on high ground overlooking the main approach road from Koblenz. Pilot number 2, Hammer, took a position covering the northern approaches. Both positions offered clear fields of fire extending beyond 2,000 yards, letting the T-28s use their range advantage. The German attack began at dawn. Infantry supported by Panzer IVs probed American positions, seeking weak points. American forces responded with artillery and mortar fire, driving the Germans back. But this was just the preliminary phase. Around 10:30 a.m., observers reported the distinctive engine sound of heavy armor approaching from the northeast. The King Tigers were coming. Sergeant Michael Chen commanded Anvil. A veteran of the Bulge, Chen had watched helplessly as German heavy tanks destroyed his previous M10 tank destroyer near Bastogne. Now peering through Anvil's periscope, he spotted movement at 1,800 yards. 3 King Tigers advancing in line formation, using terrain for cover. Chen's gunner, Corporal James Rodriguez, already had the main gun trained on the lead vehicle's projected path. At 600 yards, the first King Tiger cleared a ridgeline, exposing its frontal armor. Rodriguez fired. The 90mm gun roared, the vehicle rocking despite its massive weight. Downrange, the tungsten core armor-piercing round struck the King Tiger's glacis plate. Unlike the hundreds of previous Allied shots that had bounced off King Tiger armor, this one punched through. The German tank stopped, smoke pouring from its hatches. The other 2 King Tigers immediately sought cover, their commanders recognizing they faced an unusual threat. One attempted to flank left, using a destroyed building for concealment. Chen rotated Anvil's hull, the 4 tracks providing excellent pivot capability. At range 400 yards, Rodriguez fired again. Another hit, another penetration. The second King Tiger burned. The third King Tiger commander was more cautious. He backed into a depression, presenting only his turret, and returned fire. The German 82mm gun was devastatingly accurate. The shell struck Anvil's frontal armor with tremendous force. Inside, the crew braced for death. But the T-28's massive armor held. The shell created a large crater in the casting, but didn't penetrate. Chen's crew was shaken but alive. The duel continued for 20 minutes. The King Tiger fired 6 more times, each shot hitting Anvil but failing to penetrate. Rodriguez fired 4 times, 1 shot missing, 3 hitting but failing to penetrate the King Tiger's angled turret armor from a downward angle. Finally, American artillery bracketed the German position. The King Tiger withdrew, trailing smoke from engine damage caused by near misses. The action at Remagen lasted less than an hour total, but its impact was enormous. For the first time, an American armored vehicle had faced King Tigers in direct combat and won decisively. 2 King Tigers destroyed, 1 damaged and withdrawn, against 0 American losses. The after-action reports spread quickly through Allied command. The T-28 wasn't just a theoretical success. It worked. The engagement at Remagen sent shockwaves through both American and German command structures. Within 48 hours of the battle, Allied intelligence intercepted German radio communications discussing the new American Super Heavy Tank. German commanders, who had relied on the King Tiger's invincibility, suddenly faced a vehicle that could penetrate their strongest armor from ranges exceeding their ability to return effective fire. General Omar Bradley, commanding the 12th Army Group, visited the Remagen position on March 14, 1945. He personally inspected Anvil, examining the multiple impact craters on its frontal armor, where King Tiger shells had struck without penetrating. Bradley immediately ordered that both T-28s receive priority mechanical support and that their crews be decorated. More importantly, he authorized the deployment of additional T-28s as soon as they became available, but the significance went beyond one successful engagement. The psychological impact on German forces was substantial. Since the King Tiger's introduction in 1944, German heavy tank crews had operated with confidence that no Allied tank could threaten them frontally. That confidence evaporated at Remagen. Intelligence reports indicated that German tank commanders were now avoiding direct engagements with suspected super-heavy American tanks, fundamentally changing their tactical approach. The American response was equally dramatic. Through late March 1945, as Allied forces pushed deeper into Germany, the two T-28s at Remagen became legendary. Soldiers called them Kingslayers or Hitler's Nightmare. More practically, commanders requested T-28 support for any operation where heavy German armor might appear. The vehicles operated almost continuously through the final weeks of March, engaging various German armor with remarkable success. On March 24, 1945, during Operation Varsity, the Allied crossing of the Rhine north of the Ruhr, Hammer engaged a German Jagdtiger near Wiesel. The Jagdtiger, mounting a 128mm gun, was theoretically even more powerful than the King Tiger. The duel lasted over an hour. The Jagdtiger's 128mm gun scored 3 hits on Hammer's frontal armor, each impact spectacular but non-penetrating. Hammer's 90mm gun scored 2 hits at 1,700 yards, both penetrating the Jagdtiger's superstructure. The German vehicle was abandoned by its crew. These successes accelerated the production program. By late March 1945, 12 T-28s had completed production, with another 30 in various stages of assembly. The Ordnance Department projected that 60 vehicles would reach Europe before the war's end. While this was far fewer than the hundreds of King Tigers Germany had produced, it was sufficient to provide at least one T-28 to each advancing American army. However, the T-28 program also revealed the weapon's limitations. Its slow speed meant it couldn't exploit breakthroughs or pursue retreating enemies. Mechanical reliability, though improved, remained problematic. Most critically, the T-28 consumed fuel at an enormous rate. Each vehicle required approximately 250 gallons per 100 miles, straining already stretched supply lines. These limitations meant the T-28 couldn't replace standard tanks, but rather complemented them in specific roles. German responses to the T-28 were limited by Germany's collapsing industrial capacity. Plans were drafted for new tank designs, mounting even heavier guns. But by April 1945, Germany lacked the resources to produce them. Instead, German forces relied increasingly on infantry anti-tank weapons. Artillery and desperate last stands in urban terrain where the T-28's advantages were minimized. As April 1945 began, with Allied forces approaching the Elbe River and Soviet forces encircling Berlin, the T-28 had fundamentally altered the arithmetic of armored warfare. The rejected design had proven itself the ultimate counter to Germany's super-heavy armor. April 1945 brought the final collapse of Nazi Germany, and with it, the last desperate deployments of German super-heavy armor. The T-28s, now numbering 8 in the European theater, participated in some of the war's final armored engagements. These battles would cement the vehicle's reputation while demonstrating the brutal reality of modern warfare's final evolution. On April 11, 1945, elements of the U.S. 2nd Armored Division approached the city of Halberstadt, approximately 70 miles west of Berlin. German forces had fortified the city with a combination of infantry, artillery, and critically, 4 King Tigers from the remnants of the 503rd Heavy Panzer Battalion. These were among the last operational King Tigers. On the Western Front, intelligence indicated the German commanders intended to make Halberstadt a fortress that would cost the Americans heavily. 3 T-28s, including the veteran Anvil commanded by Sergeant Chen, supported the assault on Halberstadt. The urban terrain negated many of the T-28's advantages. Streets too narrow for easy maneuvering, buildings providing cover for German anti-tank teams, and short engagement ranges all favored the defenders. Yet the assault proceeded because American commanders believed the T-28's armor would protect assault forces during the close-quarters fighting. The battle began at dawn on April 12th, as American infantry advanced behind the T-28s. German forces opened fire. The King Tigers, positioned in prepared positions among the city's ruins, engaged at ranges under 500 yards. At such close distances, even the T-28's massive armor became vulnerable to the King Tiger's powerful gun. One T-28 call-sign Patriot took a direct hit to its track system, immobilizing it. The crew evacuated safely, but the vehicle was stuck. Chen's anvil pushed forward, using rubble piles for cover. At 400 yards, Rodriguez spotted a King Tiger's barrel protruding from a collapsed building. He fired the tungsten core round, punching through the building's remnants and striking the King Tiger's turret ring, the junction between turret and hull. The German tank's turret jammed, rendering it unable to fire. The crew bailed out. The urban battle lasted 3 days. By April 14th, American forces controlled Halberstadt, but the cost had been significant. All 3 T-28s sustained damage, though only Patriot was completely disabled. 2 King Tigers were destroyed, one captured intact but immobilized, and one withdrew successfully. More importantly, the Americans learned that even the T-28 wasn't invincible in urban combat, where ambush opportunities and close ranges negated armor advantages. The final T-28 engagement occurred on April 19, 1945, near Magdeburg. A single King Tiger, likely the last operational example on the Western Front, attempted to delay American forces crossing the Elbe River. The T-28, designated Hammer, engaged it at 200 yards across open ground. After a 20-minute duel, where both vehicles scored multiple non-penetrating hits, a lucky shot from Hammer struck the King Tiger's gun mantlet, penetrating into the turret and destroying the vehicle. By April 21st, organized German resistance in the American sector was collapsing. The remaining T-28s moved forward with advancing forces, but encountered no further super heavy German armor. Most were still operational when Germany surrendered on May 8, 1945. Of the 8 T-28s deployed to Europe, 6 survived the war in operational or repairable condition, a remarkable survival rate for experimental vehicles in frontline service. The rejected design had endured every test: engineering challenges, skeptical generals, brutal combat, and Germany's finest armor. In the process, it had helped secure Allied victory in Europe's final battles. The surrender of Nazi Germany on May 8, 1945, ended the T-28's combat career, but the debate over its significance was just beginning. In the war's immediate aftermath, military historians, engineers, and commanders argued about whether the T-28 represented the future of armored warfare or an evolutionary dead end. The raw statistics supported the T-28's effectiveness. During approximately 8 weeks of combat operations, T-28s engaged German super heavy armor on at least 15 documented occasions. They destroyed or disabled 7 King Tigers, 2 Jag Tigers, and numerous lighter armored vehicles. Critically, no T-28 was destroyed by enemy fire, though several sustained damage requiring repair. This combat record was unprecedented for any Allied armor facing German super heavy tanks. General Dwight Eisenhower, in his post-war report dated June 1945, praised the T-28 program despite its controversial origins. He noted that the vehicle provided American forces with a psychological advantage during the final months of the war, demonstrating that American industry could match German engineering when necessary. Eisenhower recommended continued development of super heavy armor for potential future conflicts. However, critics pointed to the T-28's limitations. Its slow speed made it unsuitable for the mobile warfare that had characterized the final Allied advance across Germany. Its enormous fuel consumption and maintenance requirements strained logistics. Most tellingly, only 12 T-28s actually reached Europe before the war ended, versus hundreds of Sherman tanks that bore the burden of actual fighting. Some officers argued that the resources invested in the T-28 program would have produced more impact if devoted to other weapon systems. The emerging nuclear age complicated these debates. By late 1945, as the world absorbed the reality of atomic weapons, many strategists questioned whether heavily armored tanks had any future. Nuclear weapons could destroy any armor, regardless of thickness. This philosophical shift contributed to the cancellation of the T-28 production program in October 1945. The Army retained the surviving T-28s for testing and evaluation. Through 1946 and 1947, engineers at Aberdeen Proving Ground conducted extensive trials, examining every aspect of the vehicle's design. These studies influenced the development of post-war American heavy tanks, particularly the M103 heavy tank that entered service in 1957. The M103 borrowed concepts from the T-28, including emphasis on frontal armor and long-range firepower, though implemented in a more mobile platform. By 1947, most T-28s were scrapped, their valuable steel recycled for peacetime industry. Only 2 vehicles were preserved. Pilot number 1, the vehicle that fought at Remagen, was sent to the Patton Museum at Fort Knox, Kentucky. There it remained on display for decades, a testament to American engineering and the soldiers who operated it. Pilot number 3, which never saw combat, was retained at Aberdeen for continued testing until being transferred to Fort Benning, Georgia in 1974. The T-28 story took an unusual turn in the 1970s. Pilot number 3 disappeared from Fort Benning's records, misplaced somewhere on the massive military reservation. For years, the Army couldn't locate the 95-ton vehicle. It became something of a legend, the lost supertank. Finally, in 1974, a survey crew discovered it in thick woods, partially buried and overgrown with vegetation. The vehicle was recovered, restored, and eventually joined pilot number 1 at the Patton Museum. The historical assessment of the T-28 evolved over decades. During the 1950s and 1960s, as Cold War tank design emphasized mobility and firepower over armor, the T-28 was often dismissed as a dinosaur, an overweight relic of desperate World War II engineering. But by the 1980s and 1990s, as military historians gained access to German records and conducted detailed analyses of the war's final battles, appreciation for the T-28 grew. German documents revealed the panic that T-28 sightings caused among tank crews. Former King Tiger commanders, interviewed years later, admitted that encountering the American super heavy tanks fundamentally changed their tactical approach. The psychological impact had been as significant as the actual combat results. In an era when German armor had dominated through technological superiority, the T-28 proved that American engineering could compete at the highest levels. Modern analysis recognizes the T-28 as a specialized weapon system that performed its intended mission successfully. It was never meant to replace the Sherman or to fight mobile battles across Europe. Instead, it served as a counter to specific German weapons that threatened to make the final battles for Europe prohibitively costly. In this narrow but crucial role, the T-28 succeeded completely. The T-28 story also highlighted an important lesson about military procurement and innovation. A design initially rejected by the Army's established doctrine became a critical weapon when battlefield realities demanded new solutions. The willingness of engineers like Henry Hatch to persist despite opposition, and of commanders like Eisenhower to reconsider rejected concepts, proved essential to Allied victory. Innovation often requires challenging institutional thinking. Today, the surviving T-28s remain on display at the Fort Moore Military Museum in Georgia and in the collection at Fort Benning. Visitors marvel at the massive vehicles, trying to imagine the courage required to crew such a beast in combat. The armor still bears scars from German shells that struck but failed to penetrate, silent testimony to desperate battles in Europe's final days. The rejected American design that outperformed Hitler's most advanced tank became a symbol of American industrial might and tactical flexibility. In the great contest between Allied and Axis engineering, the T-28 demonstrated that innovation, persistence, and willingness to challenge doctrine could overcome even the most formidable enemy weapons. The Super Heavy Tank may have had a brief combat career, but its impact on armored warfare history proved lasting and significant.